So we're going to be completing the square when the leading coefficient is greater than 1. Okay, so in big, bold, red letters here, I'm reminding you that in the last video we said in order to use completing the square, the value of a must be equal to 1. If it's not equal to 1, you have to divide the entire equation by the value of a. So if you take a look at my example here, I have 3x squared minus 12x plus 6, and I would like to solve using completing the square. I can't have that 3 show up at the beginning. This is my a value. That's bad. And so what I'm going to do is I'm going to divide this by 3. That's going to turn that into regular old 1x squared, which is what I want to be there. But in order to do that, I need to divide everything else in the problem on both sides of the equation by that same value of 3. Okay? And the reason that we're doing that is if you take a look at a very simple equation, like for example 6 plus 3 is equal to 9, I'm allowed to divide this first piece by 3 as long as I divide everything by 3, and my goal is that the equation just stays true. So if you notice what happens here is this is 2, this is 1, and this is 3, and 2 plus 1 equals 3 is still a true statement. It's still a true equation and it works. But if I don't divide one of these parts by that 3, this is not going to be true anymore. Like if I didn't do this middle one by 3 and I still had a 3 there, it would say 2 plus 3 equals 3, and that wouldn't make any sense, right? So as long as I divide everything in an equation by the same number, it will still stay a true equation. And so that's all we did here is we just said, I want to change the way the equation looks. I don't care what the values were. I just need to make sure that the equation stays true. So dividing the first one by 3 gives me that 1 there. I'm going to put there for emphasis that a must be equal to 1. And then the rest of the way through the problem, I'm just going to divide. 12 divided by 3 is 4x. 6 divided by 3 is 2. And 0 divided by 3 is 0. Alright? So now I'm just going to do completing the square like we normally did. We said for completing the square, use b over 2 squared. And that is the value that should show up in this location. So I'm going to move this 2 to the other side and say it's x squared minus 4x. When I subtract this over, it becomes negative 2 on the other side. Now completing the square says for us 4 divided by 2 squared, which would be 4 over 2 is 2. 2 squared is 4. So I would like to add a plus 4 to both sides. Okay. Now I can turn this into x minus 2 times x minus 2, okay, equals positive 2, right, when I add those together. This is really the same as x minus 2 squared equals 2. And so now I can solve using the square root method, square root both sides. It's going to say that x minus 2 is equal to, this doesn't square root nicely, so we're going to leave it as plus or minus the square root of 2. And then I'm going to add to finish solving, and my final answer is going to be 2 plus or minus the square root of 2. All right, and that would be my final solution. So you can see the big issue here was at the beginning of the problem, we had a number that was not 1 sitting in front of that x squared, and so we needed to fix that. Okay, so here's another example, and so this one, things are a little bit trickier. Okay, so when we divide by 2 here, we're looking at this and saying, don't want there to be a 2 there, let me divide everything by 2. We're going to end up getting some not nice numbers. So when I divide this first one by 2, I get x squared. When I do 5 divided by 2, I get 2.5. Okay? And when I divide 1 by 2, I get 0.5. Right? And so if you notice, now I need to complete the square with this. So let's find out what happens. So the first thing I'm going to do is get rid of this c value. Just like we did in the previous problem, we said we don't want this value to be there. We want to calculate our own value to put in this spot. So the first thing I'm going to do is say, leave the first 2 parts alone, but let's move the 0.5 over as negative 0.5. Okay? And so now I'm going to complete the square on this value. So the formula says b over 2 squared is equal to what we would like to come out. And so b over 2 in our case is negative 2.5, okay, squared over 2 squared. Okay? So I'm going to go to my calculator and ask it to do that. 2.5 divided by 2 is 1.25, and 1.25 squared is 1.5625. So I would really like for there to be a plus 1.5625 in this position, because that is b over 2 squared. So I added it to the left. That means I also need to add it over here, 1.5625. Okay, and we're going to simplify. So Let's simplify the right, because that's the easier one. Just add these together. That looks like it's going to be 1.0625. Okay. And on the left, we have a problem, because now we need to factor this. So if you remember what we did here, our next step was, after we completed the square, we then turned it into its factored form. So we need to think about what the relationship really is here. This number is b over 2 squared. And if you notice, when I came down here, the 4 got broken up into 2 times 2, right? And so this is a tougher example to explain because the sum and the product happen to be the same. But let me just kind of show you another quick example of what that would look like. Let's say we completed the square with like x squared minus 16, right? And on the other side, 16x. And I said complete the square on this. You would say, okay, I'm going to divide this by 2 and square it. So that would be 16 over 2 squared, which would be 8 squared. So I'd add 64 to both sides, okay? And then this factors nicely into x minus 8 squared, okay? And then I could solve this, okay? So here's what I want to point out. This value, okay, my b value, and this value that I end up with in the fraction are exactly half, right? If I do negative 16 divided by 2, I get this negative 8. So if you come over here, kind of the same thing happens. It's just a little tougher to see. If I take the negative 4 and I cut it in half, I got the negative 2 that showed up in my squared. So there's a relationship between the b value and your factored form. It's always exactly half, right? So the reason for that, I'm pointing that out, is because when we come back to this, if I want to factor something that's got decimals that I don't know the factors of, I know that the relationship is, okay, in squared form, exactly the b value cut in half. So this is minus, we said 1.25. Well, 1.25, okay? So I'm going to say 1.25 goes in those parentheses. So you can see that's a little tougher to do because you need to know about that relationship, that if you cut the b value in half, you're always going to end up with the factored form. All right, so now we can finish our problem, okay, and we're going to square root both sides. And so in this case, we're going to end up with a decimal equivalent because we're using decimals. So when I square root a squared, I just end up with x minus 1.25. And when I square root 1.0625, let's see what we get. 625, and we hit the square root button. Where's my square root button? There it is. Okay. We get about 1.03. Okay. And remember, this is plus or minus. So this is an approximation. So now I'm going to add the 1.25 over, and I'm going to get two answers. So we're going to have to split these up because they don't match. So if I take positive 1.03, again my calculator's working out, 1.03 plus 1.25, I get 2.28, so that's a possibility. Okay. If I use the positive version of 1.03, or if I use the negative version of 1.03, so I'm going to say 1.03 again, but I'd like the negative version, and then to that I'm going to add 1.25. Okay? I get 0.22. 0.22. So I get two answers that I've rounded a little bit. Okay? But you can see that when the values don't divide nicely like they did in our first problem, we're going to have to deal with decimals. You could also do this using fractions and use 5 over 2 and use 1/2. Okay, but you'd have to be comfortable with adding and dividing and square rooting fractions. Right? But that's the basic idea of this problem, is we're trying to complete the square using all of the same rules that we did here. Right? I didn't do anything that was different. I divided by the first number, I completed the square, and I moved the value over, I completed the square, I factored it. Here's where we had our kind of strange thing where we had to think about this relationship here, and then I square rooted, and I completed my problem. Right? So in this case, we did it with decimals, right, and a little bit of relationship in order to do the factoring, but the concept is the same. Get rid of the number in front of x squared if it exists, and then proceed normally through completing